Hello viewers and my dear students. Welcome to session 2 on analysis of axisymmetric solids. We were giving a demo on analysis of a closed cylinder under pressure using Ansys Release 14. This is session 2. In session 1, I have concentrated only on the theory part. Now in this session 2, I'll tell you how to do the problem using Ansys Release 14, and we'll try to get the same answers of hoop stresses what we have obtained theoretically in session 1. You see here, now the problem is this. The problem is this. This is the problem. Okay. The problem is this. That is, it is subjected to internal pressure. As you see here, internal pressure. Once it is subject to internal pressure, the pressure is here, pressure is here, pressure is here. It is not only the hoop stresses which are developed here, but the longitudinal or axial stresses are also developed because the pressure is here as well as here, because we are considering the axis of symmetry here. Okay, once you consider the axis of symmetry here, only one half you do. That means you see here, I have considered one half. In that way, here also you will have a pressure, here also you will have a pressure, here also you will have a pressure. As a result, and here also, since you have pressure here also, hoop stresses are going to develop at this fiber as well as at the outer fiber also. Okay, and since this pressure is here also, it is due to axial stress. This is the length is also going to increase, not only the diameter but also the length, because due to axial stress the length is going to increase to some extent, and due to this hoop stresses the diameter is also going to increase, and these things we will verify using Ansys. Okay, now you see here, as usual we'll start in the same way. File, clear, start new, do not read file. Okay, you say, yes you say, okay, then fit, okay, then file, change job name you do compulsorily you change job name, job name. This is for that Axi, just some name I given, enter job name. I just say okay. That means all the log file will be created in this. Okay, then file, list, log file. If you see here, it is empty. This you have to clearly know. Now I have created Gurudat Axisymmetric. Now whatever I do, it start getting collected here. You can copy the entire thing and paste it here to get the analysis done again. And you can change anything, the loads and all that, you can change instantly here. And again you can paste it here. The new analysis will be developed here. The new analysis, new stresses, everything, you can get it instantly. That is the advantage of log file operation, this log file operations and all that. Now see here, now everything is new here. I'll show you again after some stage. Okay, now you see here file, this change title also you do. This is axis symmetry problem. Okay, axis symmetry problem. Okay, this is, this you do, just say okay, fit, axis symmetry problem, you will get whatever you give the title, that is cylinder under pressure or whatever you say, you whatever you give, you get it here. The important thing is when exactly you've done, the date, time, everything you get it here and all that. Okay, now once you do this, this is this part. Now you go for preferences, structure, this is structural analysis, take okay, structural okay. Okay, then preprocessor, element type, you add, edit, delete, we'll select the element, add. For our analysis, what will support our analysis is quad 4 node 182. You just say okay, this will be plain 182. And compulsorily, I'm telling you, don't forget, here you have an option, sir. Don't take plane stress with thickness and all that what we are doing earlier. Now we are doing axisymmetric analysis. Axisymmetric you do choose. Axisymmetric compulsorily you must choose, otherwise you won't get the answer. Just say okay. Then you say close. This is plane 182 I've chosen for our analysis, and this axisymmetric I've chosen. Now this you do. Now see here, if you do here file, list, log file if you do, it would have created up to here. See here, plane 182 I've chosen, no? Up to here it has created. No, up till that only. Okay. See here, structural whatever I have done, structural is one. Other things are all zero, means I have not considered anything. Okay. In that way, whatever I'm doing, it will be getting recorded here. This you must carefully understand. Okay. Then once you do this, you take material properties. Material properties, material models, structural, linear, elastic, isotropic, and you see here this is Young's modulus for this problem is 2E5. Okay, everything I'm modeling it in Newton per millimeter square, and Poisson's ratio is 0.3. Okay, that is okay. Material exit. Okay, as you see here, I'm doing it in Young's modulus. I put it as 2E5 Newton per millimeter square. Compulsorily, you have to model it in millimeter only. Okay. Now I'll come to this modeling part. Modeling part I'll come. Modeling. Create. I could have created areas directly. Okay. The areas and all that I could have created. Now what I'll do is I'll create key points here. Okay. This method also you better you know. Key point in active coordinate system. Okay. The first point 0, 0 you take. This is key point 1. 0, 0 you take, you apply. Okay. Then key point 2 is 50, 0. 50, 0. You please refer the earlier session for the drawing and all that. This is 50, 0. This you just say apply. Then the third one is 50. This is 240. 50, 240. You say apply. Okay. Then fourth one will be 0, 240. 0, 240 is this, and then 1, 2, 3, 4 is over. Then 5 you take. 5 you take. This will be 240 means 0, 220, 220 less, 220. Okay, then you say apply. Then 6 you do. 6 is 34, I think. 34 to 20. And 7 is 34, 20. 34, 20. And 8 is 0, 20. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8. As you know here, this I have taken from this only. Okay, you please go through this. From here, I have taken this is 0, 0, 50, 0, 50, 240, 0, 240, 0, 220, 30, 220, 34, 20, 0, 20. In that way, I have all taken from this only. Okay. Once you have taken this, now you see here, I'll directly create areas. Carefully observe here, create areas, okay, arbitrary through key points you take. Through key points, carefully pick one by one. Now area 1, key point 1 is here. 1, 2, 3, 4, 5, 6, 7, 8, 1. Okay. In that way, if you create this, see here, directly you get the area. That means the axis is here. Axis symmetry I have already created. I have created the area directly. By creating the key points, I have got the area directly by this method. Now you take save db. This is very important because if you do save db, no, in case you make any mistakes later on, if I put resume db, it will come to this stage. Did you follow? That is why what I'll do now here is I have saved db here. Now in case I make many mistakes later on and all that, you resume db, it will come to this stage, you repair it. Okay, now this creation of area is over. Now what I'll do is meshing. I'll go meshing. Since it is mesh attributes, there is only one material. I don't have to attribute anything here. Directly you go for size controls. Size controls you go. Okay, all lines you go. Okay, element edge length, as you know, it is almost 50. From here to here, it is 50 length. 50 length means if I put 5 here, element edge length, every 5 mm, you are getting one element. That means in this area, element edge length is 5, this length is 50 means 10 elements you get here. In the same way, if this is 240, 240 by 5, so many elements are created here. In that way, you can do anything. Here you see here, element edge length I have given 5. Okay, instead of element edge length, number of element divisions, okay, if I give some on all lines, no, on all number of divisions on all lines, if I take, and if I give some 10 means, on all lines it will be 10. But at least here we have a meaning here. Now, here I have clearly given element edge length as 5 means, okay, this is 50 mm, edge length is 50 means, almost 10 elements are created here. Okay, and it is here in this length, it is 240 means, 240 edge length is 5 means, 240 by 5, so many elements are created. Now in this section, at least since this is 50, element edge length is 5 means 10 elements are created here. Anyway, you can verify it. Okay, you say. Then you see mesh, areas, free you say, click this and say okay. Now, see here, beautifully it has created. See here, element edge length as 5 I have taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are created here. Okay, did you follow? Now once you do this, you see here, now loads I'll go. Loads, clearly understand. Now solution phase, pre-processing is and all that over. Now what I'll do, loads I'll go, define loads, apply structural, displacement, symmetric boundary condition. On lines you take down, because here this is a axis of symmetry, this is axis of symmetry, because the other half is on the left side. That is, this is axis, this is the axis of symmetry, this is axis of symmetry. That is a symmetric boundary condition. On lines I'll click here, I'll click here also, I'll say okay. Okay, then the if you see here, SS would have created here, that is symmetry. It indicates symmetric boundary condition has been created. Then as you see here, then you give pressure on lines you take here, here and here, you have a pressure of 1 MPa, that is 1 Newton per millimeter square. You give 1 here. In that way, the pressure has been created here. Now once you do this, okay, once you do this, then the only thing left out is the solution. If you have done it correctly, you, okay, solution, solve, current LS, if you do,